Hi there, this is a problem from your lab assignment, section 2.2. Um, the problem is asking us to use a table of values to estimate the value of the limit. And then if you have a graphing device, go ahead and use it. And this is the limit that we're looking for. We're looking for the limit as x approaches 0 of tangent 8x divided by tangent 5x. Alright, so when they're saying table, I think one of the things that I'm drawn to is the Excel. And you can use Excel for this class. You can also use graphing calculators if you want. But Excel has a nice feature for tables, and we'll talk about how to use that. Alright, what we have here is step 1. To estimate this limit, we must evaluate the function for x values approaching 0 from the left and from the right. So it looks like they want us to start off approaching 0 from the right side when x is equal to 0.1. So we need to figure this out. Now you can just use a regular calculator to do this, but like I said, we do have Excel, and so we're going to take advantage of it. So we have an x value, and then we're going to have a y value, and the y value is this function. So if your x value is 0.1, what you want to do is you want to make an expression for your y value. You're going to say that you want this cell to equal to, and then there's going to be a function called tan, tangent. It's a pretty universal function, and then we're going to put in the actual number here. So it's going to be 8 times this value right here. So by pressing this value, it tells me that I'm looking at cell B3, and the cell B3 has 1. And I'm going to do this because I'm going to want it to generalize. Now that's the numerator, and then I have a denominator which is another tangent function, and this time it's 5 times that same number that we have. Okay, if I press enter, I'm going to get this value that's 1.8847407, and I suppose if we want more decimal places, we can ask it to give us more decimal places. How many decimal places do they want? They want it rounded off to 6, so let's see if we have 6. 1.8847407, and so that 07 over here will round off to 41. And so that's our 6 decimal places. Now the beauty of using a program like Excel is that if I want to have the same function here, all I need to do is change the y value. So I'm going to put a negative 0.1, which is our next x value that they want us to put in. And then I'm going to, instead of retyping this whole thing over, I'm going to click on this cell and see this little dot over here. I'm going to push it down, click and drag down, and that's going to give me another value. It looks awfully close. It looks like it's the same thing, so let's try that. 1.884741. Let's submit. And it looked like it turned out to be correct. And so they want us now to put 0.01 in for x and negative 0.01. So let's do that. Let's do that at the same time. 0.01 and negative 0.01. So now I'm essentially copying the same function and applying it to 2 different values. So this is what I get. It looks like I'm getting the same numbers, whether they're positive or negative. Okay, so let's copy that down. I don't know if you can see it. There it goes. That's nicer. Alright, so the number is 1.60, 20, and 856. Now I want 6 decimal places, so I have a 6 here, which is bigger than 5. That's going to make this 5 into 6. And it looks like I'm going to have the same number for the negative, so I'm just going to copy and paste and submit. Alright, now it's getting even smaller, 0.001. So 0.001, and then a negative 0.001. You can see that Excel is finding out that we're essentially doing the same thing here, so they didn't even bother having us do this. They did it they clicked and dragged for us already, so that was nice. So what's our answer here? It's 1.6000208. Let's be careful. Count. Whoops, that's just a function. 1, 2, 3, 4, 5, 6. So this is the 6th spot, and then we look at the 8 to be our judge whether or not we're going to round up or keep it the same. Since 8 is bigger than 5, we're going to round up, and so that's 6 decimal places. And let's check that. Okay, looks like it's working out so far. It looks like this is getting closer and closer to 1.600000 and all that. So let's see. See the value approaching the right matches the value approaching from the left. And so the value seems to converge on, I think it's 1.6. I mean, we can type in some smaller numbers. Oops, sorry. 0.00001 and negative 0.00001, for example, and then 0.0000001. So essentially it looks like we're getting closer and closer to 1.6. So I'm going to guess that the limit here is 1.6. So let's submit. Okay, it looks good. It says now you've completed it, but they suggested we take a look at the graph as well. So you can probably graph using Excel, but I'm going to move to a different graphing program. This is a graphing program that you can find online. You do have to be connected. It's desmos.com, desmos.com, and then click on Start Graphing. So I'm interested in the function y equals to a tangent 8x divided by tangent 5x. Ooh, this looks really confusing. What we want to do is we want to focus in as we get closer and closer to 0. So let's zoom in, and as we get closer and closer to 0, I'm really just concerned about tracing this function and see what happens over here. Now exactly at 0, you see that this is undefined as I'm tracing it. So I can't just put in 0. That's not good, 0 on the denominator. But you can see as we get closer and closer to that point, we get to 1.65, 1.64, 1.62, 1.61, and we get closer and closer. Before we go undefined, we got 1.602. So it looks like it's getting closer and closer to 1.6. And if you look at the graph over here, it does in fact look like it's getting closer and closer to 1.6. So I think our graph kind of confirms our conclusion from our table. And our work from our table says that we're going closer to 1.6 based on what we're seeing. All right. Okay, I hope that helps.